Okay. Hope everybody's having a nice day. The good old Monday afternoon. A fan favorite in regular learning, so even more popular in virtual learning. You got your iPad. All right. That is riveting. Cassidy, did you use your iPad to send me your performance task? What do you mean you don't know how to send it? What'd you do it on? Yeah, just email it to me. That's fine. Pictures or screenshots or whatever, yeah, just email them to me. Or some people took pictures of the work but then typed out the explanation, or some people wrote out everything and just took pictures of everything and then sent that. It's up to you. Whatever works best for you. Yeah, and I think when I last checked, I think I had pretty much everybody's, save for a couple stragglers. Yeah, any questions on that about as far as like getting the stuff to me? Anyone have any issues with that? Or again, when I last checked, it seemed like I had almost everybody. Thank you, Cassidy. Just got it. Sending right now. Awesome. Thank you. Thank you. All right. So yeah, I think I have almost everybody's. If you send me that, I don't know. I would have to double check my list. But otherwise, let's go on today then. If you have any issues, technical issues on that side in terms of sending me stuff, just let me know. Okay. So in the meantime, let's start up our next unit. Oh, wait. I forgot. I was going to talk to you guys about PFAs. Okay. We had a meeting this morning about PFAs and performance tests and such. And different teachers are doing different things, and it probably looks different in terms of your actual classes. But for us and for me, all I'm going to do is we're sort of treating PFAs like homework. Okay, so you have a PFA that you want to take, you request it. Throughout the day, I will periodically check through Summit, and any that I see that are requested, I will approve them. And that's that. Okay, that's it. We're going to keep it as simple as possible. All right, I'm not going to ask you to do anything crazy extra or, whatever. I just to keep it as it's not ideal, but just to keep it as simple as possible for everybody. You request it, I'll go through and check at various points of the day, and I'll approve it, and then you take it and you get 100 out of 10. The end. Okay, does that sound good? Any questions about that? No? Okay, I guess that's all good. So yeah, feel free to start requesting PFAs, and I'll start approving them whenever I, again, just at various points when I check. So we're going to start our next unit, which is conic sections. It'll be relatively quick. It's not the hardest thing in the world. The thing that's annoying about conic sections is there will be a lot of little details to remember. So that'll kind of be annoying, but other than that, it's a relatively quick unit, and it won't be too crazy. Okay. But so for our warm-up, let's thinking back to your best memories of your life, which is your geometry days, and thinking about how to find the center and radius of a circle if we have the standard form of a circle, which I do right here. So this is just seeing how much you remember. The center, so we look at these two values, which we call h and k. So the center would be -7, +12. And the radius would be 9. Okay, because square root of 81 is 9. So this circle has center -7, +12, and radius 9. Notice the change in sign from +7 to -7, or from -12 to +12. Okay, just don't forget that. And for the second one, so my center would be, so I'm looking here and here, but we change the signs. So +1, -4. And then the radius is the square root of 7. And we can just leave it like that. I don't want the decimal or anything. But I know you remembered all that from geometry, so no problems there. All right, so conic sections. Conic sections are what we get if we take this cool shape, which we call a double cone, right? Just a cone on top of another cone with the points touching. And so we're going to talk about how we can get different shapes by looking at different cross sections. So for example, if I had this cone and we just slice straight across it, then the shape that we can see is being made, if I take the two pieces of that cone and then take them apart and look at them, would be a circle. All right, so that's our first conic section. And depending on how we cut, we'll get different shapes. But this first one, if we just go straight across anywhere, above or below. Oh no. I almost broke my computer. Then it is a circle. Definition of a circle: it's just a set of points that are all equidistant from a center. Okay, so no matter from any point around the circle, the distance to the center is always the same. And specifically, we call that distance r, right? The radius. Which is just distance from the center to the outer edge. You might remember that the diameter is just 2 times the radius. It's double the length of the radius. Or the radius is half the diameter, however you want to think about it. But diameter goes all the way across. Radius just goes to the center. Okay, a couple general formulas that we should hopefully recognize, if not remember. Circumference is 2 pi r. Right, that just means like the distance around the edge of a circle. Okay, kind of like perimeter, right? Like the circle, the version of perimeter for circles. And area, pi r squared. Okay, so those are kind of our main circle stuff for right now, at least as far as we learned in geometry. Well, there's more stuff you learned in geometry about circles, but this is just kind of our base that we will springboard from. Okay, equation of a circle in standard form. This is exactly what we had from the warm-up. Okay, so this is the actual equation where, like I said, h and k tell me the center. And then over here on the right side is r squared. So that's why if we want to know what is just r, the radius, then we had to take the square root of that. We also have what's called the general form. So the general form is sort of like if we took that standard form and multiplied it all out, right, and brought everything over to one side, then we would end up with something that looks sort of like this. So where we have x's, x squareds, y's, y squareds, and they're all on one side of the equations, constants, and the right side is just 0. This form isn't as useful because we can't look at this and automatically know information about the circle. When we look at the standard form of an equation of a circle, we immediately should know, oh, this is the center and this is the radius. Okay, so that's what's nice about standard form. But for general form, we don't particularly have that. But we might want to know it. So let's instead talk about how can we get from general form to standard form. All right, and these are the steps that we're going to roll through. So first, we're going to move constants to the other side of the equation. So any just numbers that are by themselves, not attached to a variable of any kind. We're going to group our x stuff together, and we're going to group our y stuff together. And we're going to complete the square twice. We're going to do it once for the x's and once for the y's. All right, don't forget to consider both sides of the equations. I'll explain more what that means once we actually get to the step. But for right now, these are kind of the basic steps that we'll work through. So for example, change to standard form. All right. So, first step, I'm going to move that over. So I subtract 8 from both sides. Wow. Amazing. Stupendous. Second step, I'm just going to put my anything with an x in it together and then anything with a y in it together. So x squared minus 10x. I'm going to leave some space for myself, and I'll explain why in a minute. And then plus y squared plus 8y. Oops, actually. I'm going to leave a little bit more space for myself. Again, x squared with the x, y squared with the y. And I left a little bit of space. Because the part that people don't remember about doing this is completing the square. So completing the square is something that you did in Algebra 1, probably something you did a little bit in Algebra 2 as well, and it is something we will continue to do now in math analysis, and we'll do next year or the year after that in calculus, assuming we ever go back to school. So to complete the square, we have to add b over 2 squared. You can only kind of see that. Add b over 2 squared. So let's first talk about for the x's, negative 10 is b. So negative 10 over 2 is 5. Negative 5. And negative 5 squared is 25. So I'm going to add 25. And like the step before mentioned, well, I can't just add something to one side of an equation. Anything we add to one side, we have to add to the other side of the equation as well. So I'm also going to add 25 on the right side over here. And now I'll do the same thing with the y's. So for the y's, my b is 8, positive 8. So b over 2 squared. 8 divided by 2 is 4. 4 squared is 16. So I'm going to add 16 here. And then I'll add 16 on the other side as well, because we have to do the same thing to both sides of an equation. Once I've done that, now we should be able to factor. Okay. So I'm going to look at just these three terms, x squared minus 10x plus 25. If I want to factor this, if I think of two numbers that multiply to make 25 and add together to make negative 10, negative 5 and negative 5. So this becomes x minus 5 squared. And then do a similar thing, but for the y values. Y squared plus 8y plus 16, I want to factor it. So two numbers that multiply to make 16, but add together to make positive 8 would be positive 4 and positive 4. So y plus 4 squared equals, so let's just simplify those constants on the right side. Negative 8 plus 25, so that would be 17. 17 plus 16, 33, I think, if I know how to do math, which there's no guarantee. So this is in the perfect standard form of a circle. And like we talked about before, I can easily determine the center of this circle should be positive 5, negative 4. And I can easily determine the radius by just taking the square root of that number on the right side. So in this case, square root of 33. So biggest issue is usually just doing the complete the square part, right? Of why and how am I adding the 25, or why and how am I adding the 16? All right, but it's just doing this step right here. Add b over 2 squared. So negative 10 over 2 squared, or 8 over 2 squared. And then we have to do it to both sides. Find the center and radius. So this is the same type of question, general form to standard form. I won't do it if I don't need to, so you guys tell me. This is exactly the same process as the last question. So doing the process of completing the square and factoring. Should I go through this again? I'm happy to, but I just don't want to if it's redundant. If you already feel comfortable with it, you don't need to. Perfect. Anyone else have input besides Emmy? Good. You're good. You're good. You're good. We're good. Okay. Okay. Cool. All right, so let me go past here. Find the x and y intercepts. Win, 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 win. X and y intercepts. So we've done problems before where we say find the x-intercept, find the y-intercept. Right? So let's just say we want to start with the x-intercepts. So even if we don't know a particular rule, like for rational functions or something, and we are asking how do we find certain intercepts, well, remember, we always just plug in the opposite variable for 0, or 0 for the opposite variable. So to find an x-intercept, I know that the y value should be 0. So I'm just going to go through my equation. Not equals, plus 0 minus 5 squared. So 0 minus 5 is negative 5. Negative 5 squared is 25. So I arrive here at this. And now it's just a matter of solving for x. So we'll subtract 25 from both sides. To get equals 20. Get rid of the squared, so we take square root. Remember, when we take square root, we need plus or minus 20, or plus or minus, so plus minus root 20. And then subtract 6 from both sides. So negative 6 plus or minus square root of 20. And actually, I'll go one tiny step further. By simplifying square root of 20 into 2 root 5. Because remember, we can think about square root of 20 as square root of 4 times square root of 5. And square root of 4 is 2. And then don't forget how annoyingly picky I am. Since this is an x-intercept, we actually want to write the coordinate Okay, so there's the x-intercept part of my answer. So there's 2 x-intercepts, which makes sense. Right, we could have more than one. We're talking about a circle. So the circle could definitely be intersecting the x-axis at more than one spot. And then for the other part of our answer, finding the y-intercepts. So this is exactly what we did for polynomial and rational functions. If I want to find a y-intercept, then we'll just plug in 0 for x. So 0 plus 6 squared, so that would be 36, plus y minus 5 squared equals 45. And we'll go through the same process of solving. We're just isolating y. So first I'll subtract 36. So 9. Square root of both sides. So we would get plus or minus 3. Don't forget the plus or minus. And then add 5. So 5 plus or minus 3. So 2 cases. 5 plus 3 is 8. 5 minus 3 is 2. So I'll have 2 of these intercepts, 0, 8, and 0, 2. So if we have actual numbers with the plus minus part, like 5 plus or minus 3, yeah, we can easily calculate those, 5 plus 3 and 5 minus 3. But if we end up with something like this, negative 6 plus or minus 2 root 5, well, this is as simplified as we can get it, and we're not going to do decimals. So we're just going to leave it like this. That's why on the right side with the y-intercepts, I went ahead and actually did the math. But for these, I can't actually do this, negative 6 minus 2 root 5, negative 6 plus 2 root 5. The only way I could do it is just by getting decimals or something. So that's why I left it like that. But all it comes down to is the same thing we've been doing with functions forever, all the way back to algebra 1. All right, something we can do is if we want to know x-intercepts, then plug in y equals 0. If you want to know y-intercepts, then plug in x equals 0. And we can already immediately know the center and radius from this problem. Right? -6, +5 is the center. Radius, square root of 45. Next up, a line that intersects a curve in exactly one point. And on a circle, this point is exactly perpendicular to the radius. So this is what it looks like, this blue line here that is just skimming across the circle, and it only intersects it in one point. That exact one point. Does anyone remember what this type of line is called? From my wonderful students here. Again, back to your geometry days. Bust out the old notes. Secant. No, not quite. It's close. It's in the same kind of family as secant. Secant is if it can touch it twice. But if it just skims across it once, there was a different name. But that's a really good guess. Okay, we call it a tangent line. And this will be crazy important for us going forward in calculus. You know, we'll talk about tangent lines almost every day for an entire year. Okay. SOHCAHTOA, there you go. Is that the one thing you remember from geometry? Is just SOHCAHTOA? So that's good if so. That's a pretty key piece. Okay, and so from this second bit of information, so if we have, this is our radius, it turns out that these are always perpendicular. Okay, this will always create a 90-degree angle. So from anywhere, if I draw a radius and then a tangent line that goes across it and touches it at that same point, same deal. This would be a 90-degree angle between the tangent line and the radius. Okay. Oh, nice. I already did all the work on there. Let me erase that then and come back. Forgot to clear it. So find the equation of the tangent line through the point -1, 9. That is on the circle that has center 4, -2. Okay, so there's a lot going on here. But let's say the center, it tells us, is 4, -2. There's this other point that is on the circle that's -1, +9. Okay, so I don't know. We'll say that's, right here. And we want to know, so the tangent line that just skims across it, what would be the equation of that line? All right, well, for any equation, we need a couple things. We need slope, and we need to know some point that's on the line. That way we can use point-slope form, which we've used a few times throughout this semester. Okay, but the first question I ask myself is, what is the slope of this line? Well, I'm not sure, but let me first think about what is the slope of the radius. Or at least that radius that I drew right there. Because I have 2 points, and so we know how to find slope, right? Our slope formula is y2 minus y1 over x2 minus x1. So 9 minus -2, -1 minus 4. So 11 over -5. Well, that's actually super helpful to me then, because if I know the slope of the radius, I should be able to automatically know the slope of the tangent line because of that special property that we just mentioned, where we know that tangent lines, whenever they connect with that radius at that point, it creates a 90-degree angle. They're perpendicular. So back to geometry. Perpendicular lines, their slopes are opposite reciprocals. So they're change sign and you flip the fractions. So the slope of the tangent line should be positive 5/11. Right, so the slope of the radius is negative 11/5. So I flip the fraction and then I change it from negative to positive. So this is the slope of the tangent line. Now I have a lot of key information here. I know the slope of the tangent line. I know a point that is on the tangent line, -1, +9. So now I have everything that I need in order to go through and actually figure out what is the equation. By using point slope form. So as a reminder, that's y minus y1 equals m times x minus x1. So m we know is 5/11. The x value, so my point is this -1, +9. So that would be x plus 1, y minus 9. So it's just substituting all that stuff that I know. And now we'll just simplify this down so that we can actually get a slope-intercept form, y equals mx plus b. So I'll first distribute y minus 9 equals 5/11 x plus 5/11. Add 9 to both sides. So off to the side here, I'll do 5/11 plus 9, but I need there to be a common denominator. So really that's 5/11 plus 99/11. 5 plus 99, 104/11. So this is the equation of my tangent line. All right, it took a little bit of work to get there, but all tools that we've used before. Okay, we know slopes of perpendicular lines our opposite reciprocals. We know how to use point slope form, right? We know how to find a slope, y2 minus y1 over x2 minus x1. So really it's just combining a bunch of these pieces together to then figure out this kind of new type of question, this new problem. Any questions? This will be such a common question in calculus that you're asked, you know, not exactly looking like this, but the amount of times that you'll be asked to find the equation of a tangent line in calculus is uncountable. It's insane. We're still doing it. You'll do it the entire year in calculus. So knowing that point slope form and how it works is going to be critical. Okay. That's all I have here. Hey, make sure I'm about to go look through my email and count up everybody's that I have. And so whoa. Can you guys still hear me? I kind of freaked out there for a second. Assuming you can still hear me though, I'm going to go check my email. Anybody's that I don't have, I will send you an email that says, hey, I don't have your performance task. Okay, so even if you know you turned it in already, still double check your email here in the next 10-15 minutes, because maybe it got lost in the shuffle or something. And so if you get it so that you know, hey, Mr. Abundis said I didn't turn in my thing, but I know I emailed it to him. So maybe I just can't see it at the moment, or maybe I need to reorganize my folder. But I'm going to send an email to anybody's that is missing, right? At least that I don't have it right now. So you can double check to see if I have it since you did or didn't turn it in. Okay, but I think I have everyone's. I'm maybe just missing one or two that I'm aware of right now. So double check though. Look for that email that will say that it's missing. If I do have it, then I won't send you anything. Okay. Any questions for me about the performance task, the